Welcome to Chapter 7, and the material that I'm pulling from is the handout that I've given you in class, last class. First thing we want to do is take a look at our data here and decide, who's going to be the x variable and who's going to be the y variable. Now, in this particular data set, I believe that guessing the size of a diamond based on the cost of the ring, or guessing the cost of the ring based on the size of the diamond, is pretty much the same thing. I don't think one is necessarily a better fit. But in the handout, it says to actually create a model that predicts cost from the size of the diamond. So if we're going to predict costs, our y value is always the predicted value. Okay, so we're going to use the caret size as our explanatory variable. The response, or we're using the size of the diamond to explain for the cost of the diamond. So our cost then is going to be y, and that's a tricky one for the status. That's why I chose this one, is because it's often we see the first list and we just throw that right into our x list. So we're going to take all of these values, press pause, and put all of your caret values, right? All of these caret values in the order that you see them. I went top to bottom, top to bottom, top to bottom, and then I put that in list 1, and top to bottom, top to bottom, top to bottom, list 2 for my dollar values. Then go into your calculator, go to stat plot, go to plot 1, select scatter plot. That's the very first selection. It's like a couple of dots. It looks like this in the calculator. Select that version and take a look at the scatter plot. And the scatter plot should look something like this picture right here that I have. Mine's a little bit of an exaggerated version. So get that done, then press unpause. So we've already sketched a scatter plot, and now we want to describe that scatter plot as part of number 1. And remember, there are 3 pieces that we want to say. All right, so what's the shape look like? Looks roughly linear. Strength, it's fairly strong. And direction, positive association, meaning that as the size of caret goes up, so does the dollar amount, right? This trend is trending in this direction. So, roughly linear, fairly strong, positive association between diamond size and cost, remembering to get the context of the question in there. Now, number 2 says, let's create a model. First, the basics of the model. The model is y hat. This is our estimated value. And this little hat on the top indicates that that's not an actual value, but a guessed value. Our estimated value of the cost of diamonds, or of the diamond ring, is equal to b naught, that's b sub 0, which is our y-intercept, plus b sub 1, which is our slope, times the size of the caret, times the size of the diamond in carats. And you might want to take a second to add in all of that information that I just placed on there for you. But again, it's the estimated value in dollars, and then the actual value in carats. Okay, how do we get this model to show up? Well, that's the best part. We're going to do it in one of 2 ways. The first way I'm going to do on this video, the second way I'll do in class. In the video, we're going to use the calculator. Now what this all hinges on is that you have the data in your list totally correct. So make sure that your carats are all in list 1, double check all the values, and make sure that your dollars are in list 2, double check all the values. You should have equal amount of values. And now you want to do something critical, and this is a one-time deal. You're going to go into the calculator and go to second, the second button just below y equals, second, and then the 0 button. You'll see the word catalog above it, okay? Second catalog, that's the 0 button, and then arrow down until you see diagnostics on. You're going to hit enter, and that's going to put diagnostics on your screen. Hit enter again, excuse me, hit enter again, and it should say done. Now once you got that done, go to stat, calc, linear regression a plus bx. It's choice 8, not the first one. The first one says ax plus b. Make sure it's the a plus bx. It's choice 8 on most all the calculators. And then, depending on which one you have, it's going to ask for an x list, y list, yada, 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 and function. Or if you have an 83, L1, comma, L2, and then for where it says function, or for the 83 users, you're going to go to vars, right? That's below the arrow button. Vars, y vars, function, y1, and press enter. And you should have a nice set of output on your calculator that says the following. Up at the top, it just says linear regression. That's what we ran. Y equals a plus bx. That's the version you chose. And you have an a value of negative 558.52. B is 8225.06. R squared 0.9875. And R, which is the square root of R squared, 0.9937. Okay, let's talk about what all this means. First of all, your calculator has not the best notation, so let's line this up. Your y hat is what the calculator is calling y. Okay, that's the estimated value. We don't have a number for that. That's what we're guessing based off of different values for x. Your b naught, your y-intercept, is the a value, so a is negative 558.52. b1, your slope, is your b value. That's the A225.06, and x value is any given x value that we put in this case, size of diamond. In other words, the cost estimate, my guess on how much a diamond ring would cost, is negative $558.52 plus $8,225.06 times the size of the ring in carats. That's our answer to number 2. So as you can see, this is really just a simple procedure of careful entry and then taking this information and putting it into a useful form and context. So we're going to skip over number 3 and go right to number 4. Number 4 asks for an interpretation of the slope. So here's our slope. And remember that in Algebra 1, the slope is change in rise, or change in y value, over change in x. In statistics, we're going to just put this over 1. So remember that this 8225 number is your change in y value, and the 1 is the change in x. So 1 refers to carats, and 8225, right, carats, and 8225 refers to dollars. That'll help make sense of this sentence now. So for each increase, because remember the slope is positive, this is going up. For each additional carat, right, for 1 carat additional, I would expect an increase, or the model predicts, right, because this is a predicted value, not an exact value, and an increase in cost of 8225. Seems reasonable. For number 5, it asks us to interpret the slope of the y-intercept. Remember that the y-intercept in any model is always when x is 0, the value of y. So our value of y is negative here. So we would say the model suggests, again, it's a suggestion, that a diamond of 0 carats, right, when x is 0, if this was 0 right here, you'd multiply this would all go away. The only thing that would be left, arithmetically speaking, is this number. So when x is 0, or when carats is 0, the model suggests that the diamond would cost approximately negative $558. Generally, it's not uncommon for the y-intercept to not make sense. When we translate it into context, it doesn't make real-world sense. It's an adjustment number that makes the overall model work. The next 2 questions, 6 and 7, can be answered by referring back to our output from the calculator. R squared and R have been given. The correlation is the strength numerically of the linear association, and that value is always going to be somewhere between -1 all the way to +1. So R has to be between those 2 values. Now, it's funny, these values, -1 and 1, would explain for perfect linear association. The closer to 0 you get, the closer to no association. So 1 and -1 are equally strong. It's just whether or not you have a positive association or a negative association. Remember, we said that this was a linear, positive, and pretty strong association. And we should see a number then. If we say it's fairly strong, it should be a number that's, I'd say greater than 80.8 up to 1. And we have an R value of 0.9937. So number 6 is simply answered by just saying 0.9937. Then they ask us to explain the meaning of R squared in context for the problem. Now, when I look at the definition of R squared is the amount of variability in y, or variation in y, that can be explained for by the variability or regression on, because that's what we're doing, we're regressing on the x value. So that's our procedure. So what percentage of the change in cost values of rings can be explained for by the change in size of diamonds? That's what we're saying. I mean, doesn't it seem that the bigger the diamond, the more expensive the cost? Of course. But what percentage of that fluctuation in cost can be explained for by the diamond itself? Let's take a look. One of the main things to do is to turn this number, 0.9875, into a percentage. So we shift the decimal place or multiply by 100, shift it over 2 spots, and we get 98.75%. So 98.75% of the variability in cost can be explained for by the variability in size of the diamond, at least for the set of data that we have here. Now, perhaps this is all white gold or all platinum rings. We know that the change in the metal or the medium that holds the diamond will also be a huge factor in the cost of the diamond. But in this given set of data, the difference in the cost of the diamonds is 98% of the reason why they have differences in costs are associated with the size of the diamond. That's it. It's a pretty handy and powerful tool when you really think about it. This brings us to the last question about residuals. Okay, before we answer number 8, let's take a look at what residuals is. It's the actual difference between, or I should say the difference between the actual value and the predicted value. Remember, this is a predicted value, that Y hat. I like to reduce it down to an acronym, RAP, like the music. Residual equals A minus P, actual minus predicted, because minus means difference or difference means minus. So how do you get a positive residual? Well, if A is bigger than P, A minus P would be a positive number. That means P was smaller than it actually. P generated a value that was a lower prediction than what it actually was, or you under-predicted. What happens if P is bigger than A? You over-predicted. P is bigger than A, and therefore A minus P would be a negative number. So a negative residual results from an over-prediction, and a positive residual results from an under-prediction. Which one's better? Depends on what side of the fence you're on. Let's take a look at our model. How about a 0.19 carat diamond ring? It's kind of a small diamond ring, okay. We multiply that times our value here first, then we subtract the 558, okay. And what does a small diamond ring cost? It costs about $1,000. All right, it's kind of expensive. Yes, diamonds are expensive. And that's what we're guessing it's going to cost. What did it actually cost in our list of data? It actually costed $1,076.18. What's 1,076 minus 1,004? $71.94. That value is positive because it was an under prediction. So let's answer the question. Would it be better for the customer to have a negative residual or a positive residual? Well, this is a positive residual, and that means that the customer would have paid, a value that's less than what it actually costs. So I think from a customer perspective, it's better to use this model to generate a price and have a positive residual, because that means that the value they predicted was lower than the actual cost, thus saving them a little bit of money, assuming that the dealer took that value as a sale price. So now what? Go to Quiz B. Go to Quiz B and attempt the following questions. 1 through 8, omit number 3. Good luck. See you next class.